Welcome back to the 19th part of Debugging at Scale, where we can pinpoint the exact revision in which things went south. We don't typically think about Git as a debugging tool. Sure, it's a great tool to study the history of a file and narrow down causes, but as a debugging tool, it can be used for one special case of debugging: regression test track tracing. In this module, I cover a lot of magical tools, and Git Bisect is one of the best examples of such a magic. The hardest part in debugging is knowing the general area of the bug. Bisect literally shines a light on the specific commit that caused it, if it's a regression. Before we begin, let's make one thing clear. Bisect is a tool for finding regressions. It does nothing for regular bugs. When we have a regression, we typically know that the issue used to work in a specific release. We would typically have a specific revision where the code worked. We would know that it doesn't work in the current version, but which commit along the way caused the failure. Back in the old days of SVN or CVS, SourceSafe, etc., we used to check out an old version of the repository and test on it. If it failed, we'd go further back and forth, and if it succeeded, we'd go forward to hone in on the specific commit that failed. Those among us who were lucky enough to work with competent QA departments would often pass this task to them. Ultimately, the work was manual. When zeroing in on the issue, we'd follow the sensible search strategy of dividing the number of revisions in half and going to the middle of the set instead of going one step at a time. This significantly shortened the time spent looking for the problematic revision. However, there are still many revisions to search through. At this point, you might wonder, why didn't you automate these things? We sometimes did, but since no versioning system was as dominant as Git, these automations didn't last, and I'm not aware of such an automation that made it into any version control system. But Git Bisect made it in, and is the automation of this heuristic. Git Bisect does that. The simplest use of Git Bisect starts with the command git bisect start. This switches us into bisect mode. We can now define the good version where things used to work properly. For instance, in the Codename1 repository, I can use the revision that you see here as the good revision. We can mark this revision as good using this command. By saying the revision is good, we say that the bug isn't reproducible in this revision. Once we do that, we can activate bisect traversal by marking the bad revision. For most cases, this means the current head revision, which is the default. But we can also specify a revision as an argument to this command, just like we did in the good command. Normally, we don't need to specify a revision in the bad command, and I didn't in this case. Once this is done, we can move between revisions by redefining the good or bad revision. I ran these commands in the Codename1 repo and got the output at the bottom. Notice the value here at the bottom. This is the current revision we jumped to. We can now mark this revision as good or bad based on our manual testing. I marked it as bad. I could have marked it as good, and that would have worked fine. This moves bisect to the next revision we need to test. Every time we move, this number is cut roughly by half. So initially we have 8 revisions. The dumb way to test would be step over the 8 revisions until we find the bad one. The smart process jumps to the middle tests and can eliminate half the revisions with each cycle. That's why Bisect says that roughly 3 steps remain to finding the problematic revision. This is very cool. We used to do this manually and it was very confusing process, but this still isn't ideal. I might incorrectly mark a good revision as bad or vice versa. Also, just checking the revisions manually every time seems tedious. Can we automate this thing? Before we proceed, if you followed along with me, you can stop the bisect process by invoking git bisect reset to exit the bisect mode. Now that we got that out of the way, going through every revision manually is a major pain. It's better than randomly going through revisions, logs, and jumping through revisions while keeping our place in our head, but just barely better. Luckily, there's a better way: run. Bisect can run an arbitrary command for us on every revision it encounters. If the command returns 0 as a process exit code, the revision is good. If it returns something else, it's bad. This way, the broken revision will be identified automatically for us with no human interaction. To do this, I first need a test case, a simple shell script that will fail if the test class doesn't pass. I want this to be relatively fast, though, so I don't run all the other tests. I can save this shell script and pass it to Git. I can now run this shell script on revisions between the good and the bad revision. This will follow the standard Bisect process, so it won't execute on every revision. It will go back and forth until it finds the commit where the test broke. Notice that if compilation will fail because of dependencies within the test case, you might end up with the wrong revision. So keep the test simple. Git Bisect is probably the simplest tool I will cover in this chapter, in this module, but it's also one of the most important tools. Learning to use it effectively can save you days of tedious work and hunting around for an issue. Despite these huge benefits, it's a relatively obscure feature. The reason for this is that most of the time we don't need it. But when we do, we really need it. Hopefully, the next time you run into a regression, you'll remember that it's there and use this process to hunt down the issue. In the next video, we'll talk about JMX and JMX term, the most important Git command that's relatively unknown. If you have any questions, please use the Slack channel to ask them. Thank you.